Obviously, there's not a lot of people here. Feel free, it'd be more fun to keep this interactive. So feel free to. Oh, thank you. But please shout out if you have any questions. And if someone here could monitor Teams and let me know if there's any questions on Teams, that would be awesome. Let's get rid of this. All right. We good? Hey, Alex, can you verify that my screen's showing up?
It is.
Cool, thank you. All right, so I'll repeat what I just said though. Please shout out if you have any questions. It'd be more fun to keep this interactive, especially with with this many people. Alex, if you can keep an eye on Teams, and if anyone posts questions in there, let me know. So I'm John Bush. Work as a VMware solutions engineer. I work in their modern application business unit. VMware is a pretty big place. The modern application business unit is where they focus on things like Kubernetes and containers and technologies related to that. But I've only been in this role for a few years. I've spent the bulk of my career as a software developer, over 20 years actually. I got started, I've probably been around as long or maybe even longer than Kevin. I started on doing AppleSoft Basic on an Apple II Plus back in the day, and I guess I've been programming on and off ever since. When .NET came out in beta, I was at a company that was thinking about, we needed to develop a GUI for an application, and we were looking at VB6, and I really didn't want to do VB6, so I talked my manager into letting me try .NET, and even though it was still in beta form, and I used WinForms, and I started with .NET at that point in time, and stuck with it all the way through .NET Core. But anyway, that's enough about me. So today, as the title suggests, we're going to be talking about building a .NET application. We're going to talk about containerizing it and talking about different ways you can accomplish it and the pros and cons of each. And then we'll also look at taking that containerized application and deploying it to Kubernetes. And we're going to deploy it into a Kubernetes cluster running right here on my local laptop, as well as to a cluster out in the cloud. So with that, I guess we'll get started. And by the way, I'm going to jump. This is not a slide-heavy demo. There's going to be a lot of time that I'm spending in the terminal and in the editor. So I'll try to increase font sizes to make things more easily readable. So the intent of this presentation is to really show you building the app, containerizing it, and running it in Kubernetes, and not just talking about it with a bunch of slides. Whoops. So let me get that situated. So is that big enough, or do you want me to increase the font size even more? Yay, nay, good? Okay, cool. Cool. So obviously, if we're going to build a .NET app and containerize it, we first need a .NET app to start with. So I don't have a pre-made app. I'm just going to have .NET gen up a little starter app for us, and I'm going to do that by saying .NET new MVC, and I'm going to create a new ASP.NET MVC application, and I'm going to call it .NET demo, and we're going to use that as our starting point today. And so this is just using, and by the way, I'm doing .NET 5 this evening. So we should now have our app. And I'm going to bring it up in Visual Studio Code, and we're going to make a couple code changes to it before I bother to run it. There's a few things I want to add to the default, to the project that gets generated, just so that when we do run this in Kubernetes, it'll help me illustrate a couple things. And I don't want that. So I'm going to modify two files in the project that gets generated. Again, this is an ASP.NET MVC project, so I have a controller called home controller, and I'm going to replace some of the code in it. And let me go over here. I've got the code already saved off to the side in a GitHub repo. And I'm just going to cut and paste it, and then we'll talk about what changes I made. All right, so here's the home controller. I'm just going to paste in the code that I stole out of my GitHub repo, and we'll walk through the changes here. And let me make this a little bigger too. And by the way, if anybody can't see anything, please let me know. Stretch this out. So this is the home controller. The only changes I've made to it is that I've added this logging message to it, so that when someone visits the index action, it basically just prints the current date and time out. This way, every time you hit the page, it logs the time that you accessed the index action. I've also added a function that's going to retrieve some data from SQL Server, and this is something I've added for the very end of the demo because I want to demonstrate. So we're going to demonstrate taking this application and deploying it to Kubernetes. And that's all well and good, but in reality, real applications almost always talk to a database or a message queue or some sort of backing data store. So I want to make sure I included that in the demo. So at the end of today's demo, we are going to show deploying SQL Server into a Kubernetes cluster and have this app connect to it. In the meantime, before we have SQL Server up and running, this function getSQL Server table names, which is defined down here, has a big try catch around it, and it's going to error off initially until we deploy SQL Server, and we'll see an error message on in the web application until we get this fixed. But that's to be expected. So those are my two changes to the home controller. The other change I want to make is, again, we added some code to this index action, and I need to make some accompanying changes to the index actions razor view. So I'm going to come over here into views, go to index.cshtml, and again, just to save time, I'm going to go over here and steal my code changes, and then I'll tell you guys what I did. So views, home, and let me steal all this. And again, there's nothing earth-shattering about this. There's a couple things I'm doing, again, to illustrate some things when we get to Kubernetes. I'm retrieving the value of two environment variables here, pod name and pod IP, and I'm printing them down here if they have a value. They won't have a value until we deploy this app to Kubernetes. But these will become significant later. I'm also, just for fun, I'm printing the current date and time on the screen in UTC time zone, just so that every time we refresh the page, something changes. It'll update the time. And then here's where we'll print out whatever data we're able to retrieve from SQL Server. And that's it. Those are the only changes I'm making to this app. There's nothing earth-shattering about it. Those are the code changes. I do need to do one more thing. I need to say .NET add package Microsoft.data.SQL client, because I've added code that talks to SQL Server, so I need to reference the NuGet package that allows me to communicate with SQL Server. So I'm going to do that. And now I can say .NET run, and we're going to run the app. And get ready to be impressed. So I'm going to go to localhost, localhost 5000.
I'm very impressed.
Yes, with the error, yeah. So this is the web page that we'll see. And again, this is nothing super exciting. We have a home page, we have a privacy page. And as I said, we've added the current date and time on here. It's, I guess, in UTC time zone, it's 11 p.m. And again, when we're able to talk to SQL Server, we'll see a list of table names that it's querying SQL Server for here, just to show that we were able to communicate to SQL Server. In the meantime, we're gonna get this error message that says it can't reach SQL Server. So I think we're good. We have our application. Now the next thing is we want to package this application up as a container. And before we get into that, I do have a couple slides that I want to run through. And do this. So does everybody here, how many of you use containers in your job today regularly? I guess Jeff uses a lot of them. That's good. So I guess let's just talk about like what containers are and why you might be interested in using them. So as it says here, containers allow you to package up your application with the application runtime and all its dependencies. And the purpose of this is you want to take everything your application needs, put it in a container, and then you can carry this container around, and whatever environment you place it in, it should run it should always run the exact same way, because everything the app needs is in the container. It's not depending on anything in the environment, or if I move it from my corporate data center out to the cloud or run it on my development machine, the app's using all the files that the application uses are in the container itself, and it's not dependent on anything outside that container. So you get consistency, and that consistency is it essentially fixes if you're a developer, everyone said, well, it runs on my machine. That goes away with containers, because if you package your application up as a container, it'll run anywhere that you put that container. Containers are similar to virtual machines, but they're more lightweight. I'll have a little picture to depict that in a second. I wanted to just point out that we're going to be using Linux containers in this demo today, but you can also create Windows containers. So if you have let's say you have a .NET framework application that only runs on Windows, you still can use containers. And last but not least, I just wanted to point out, I think a lot of people think containers are strictly a Docker thing, and Docker invented them. And the company Docker was definitely an OG or an originator of this container technology. But containers are actually, see if this works. They're actually, the specification for a container is driven by this organization called the Open Container Initiative. And it's actually a collection of companies. If we go down here, all of these companies participate in this organization, and they collectively decide on the format of containers. Now you'll see Docker's in here, Amazon, Google, Microsoft, etc. But my point here is containers are not a Docker thing. They are an open format, and containers can be used by applications other than Docker. You can run containers in Docker, but you can also run them in Kubernetes, and there are many other applications that can consume containers as well. All right, so I mentioned containers are more lightweight than virtual machines. I just wanted to do a quick, I assume everyone is familiar with a virtual machine, and if app one, this column here represented a virtual machine, and you had application one in that VM, that VM would contain not only the application, but all its dependencies, the binaries and libraries, and then it would also have to contain the entire guest OS, whatever operating system the application is sitting on top of. The difference is with containerized applications, if you look at app one on this side, the operating system is shared with the host machine. So when I containerize my application, if I containerize app one, the container only needs to hold on to the application and its dependencies. The container does not need to contain the operating system. And if I'm being pedantic about it or strictly accurate, all containerized applications are sharing the host machine's operating system kernel. But the end result of this is, because the container does not have to contain the operating system, containers are smaller, they're more lightweight, they take up less disk space. And I added this today. I'm not sure that this slide's strictly necessary, but I did want to point this out. I realized when I was practicing this presentation that I throw around words like container and image, and I wanted to make sure everybody knew the definitions of these, and because there is a difference. So an image is a file. An image is an inert, immutable file that's just sitting on your file system. It's like a JPEG file or a Word.doc file. And a container is created by running an image. And I like this programming analogy. I assume most of us here are developers, but a container image is analogous to a class, and a container is an instance of that class. So what follows from that is if I have a container image, which is a file, I can run it to start running a container. And I can take that same container image and run it 2, 3, 4, 5 times and create more containers from that image. And anyway, so just to get clarity around those two terms, I thought it was worth bringing that up. But enough talking. Let's get back to our app and talk about how we take that ASP.NET MVC app and containerize it. And the way most people containerize applications nowadays is using Docker. And Docker has this facility, or has the ability to build container images using something called a Docker file. And I actually have a Docker file I was going to show you guys. Right down here. So, and admittedly, this is a sort of a worst case scenario of a Docker file. This one's particularly complicated. I'll zoom in a little bit. If you scroll down here, there's a lot going on. But a Docker file is a text file with a bunch of instructions, and Docker processes this file from top to bottom. And I'm not here to really teach you how Docker files work. I'm just sort of talking about them more at a high level. But Docker desktop, like I have running, which is, by the way, I probably should have introduced this. On my machine today, I'm running Docker Desktop, which is a product made by Docker, the company. Docker Desktop is a tool that you can run on virtually any operating system. It lets you build container images, it lets you run containers, it lets you administer and manage containers as well. And as far as building containers, you do it by creating a Docker file with these commands in it, like you see here. The reason I pulled up this Docker file is just to show that Docker files aren't necessarily simple to create, and they're not, especially if you're interested in creating an optimal Docker file, or excuse me, an optimal container image. And an optimal container image is really just an image that only has within it the absolute minimum set of files necessary to run your application. And it's not bloated with other stuff that your application isn't using. But at the end of the day, creating or writing a good Docker file is a bit of a black art. It's not easy. But that said, so again, what I'm showing you right here is a bit of an unfair, example of a Docker file. This is probably one of the more complicated ones you'll ever see. Let's try building our ASP.NET MVC application with a Docker file. And I'm already have a Docker file I wrote over here, and I'm going to again cut and paste this. And we'll go over here, and I'm going to create a new file. I don't want it in the home folder. Let me do this. Save this. That's all right. I'll move it. It's going to put it in the wrong folder, but that's okay. Don't go there. Hold on a second. Docker file. Let's try it this way. I'll drag it down here. Yes. All right. So I'm putting it in the root of the project folder. But so this is my Docker file. This Docker file will build this little MVC application we built. And more precisely, this is a more sophisticated type of Docker file because it's what's called a multi-stage Docker file. It doesn't just build a container image. It builds the application. It does a two-step operation, I guess, hence the fact that it's multi-stage. It builds the application. It takes the build artifacts after the application's built, and it copies them into the output container that contains the runnable, the container that you use to run your application. And so if you look in here, you can see it's building your application. It's running things like .NET Restore, which if you've used the .NET command line interface, you should be familiar with, and .NET Publish down here. So it's building the app. You don't have to build the app ahead of time. It's going to build the app for you in sort of an ephemeral or temporary container. Once the application's built, it's going to create an output container, and that's going to happen down here. And it's going to essentially copy, in this line here, it's copying from the build container all your build artifacts and putting them in the runtime container. And ultimately, this is creating a smaller container that essentially it's doing this because we want the resulting container to only contain the files necessary to run our application. We don't need the container to contain the files that we use to build the application.
Why is that so important?
I mean, you could argue that it's not. To some degree, it's just you're making the container smaller. You're saving disk space. I don't need the whole .NET SDK in the container that runs my application. Again, you're probably again. I think it largely boils down to a disk space savings. Yeah, because otherwise you're carrying around in your run container all the things that you use to build your application, and oftentimes those things you use to build your application end up bloating the container quite a bit, and so you're sort of carrying around the stuff you don't need. But let's try running this Docker file. I'm going to go back to my terminal over here. And so Docker, the little whale icon you see up here, when you install it, when you install Docker Desktop, it comes with a tool, a command line tool as well, just Docker. And this allows you to issue a bunch of commands to Docker to do things like build containers and run containers. In order to run or to build this file, I'm going to use a command called docker image build -t .NET demo Docker file, and then a period at the end. And so if you look at the directory I'm in the folder with all the files, all the .NET files for my application, program.cs, my CS proj file, etc. And I have my Docker file in here. This command is telling Docker, build an image. The -t parameter is saying tag it with this name. So when it builds the image, it's going to tag it with the name .NET demo Docker file. And the period at the end is basically telling it to use the Docker file that's in the current directory. And it's going to read that Docker file and follow the instructions from top to bottom and create a container image. Oh, but you know what? I missed a step. So I have to. So this error is because it copies as part of the build process. So when I ran the application earlier, it built it locally on my machine, and it created a bin and OBJ folder locally for the application. And those folders, I don't want. I need to remove those because the multi-stage Docker file is going to do the build for me. And if I leave these files sitting around, they get in the way of the build and prevent it from completing successfully. So if you look at what I did, all I've done is I deleted the OBJ folder, I deleted the bin folder, and now I'm going to go back and I'm going to rerun Docker image build. So it's building the app. This shouldn't take very long. And it's done. So you can see down here, if you recall from looking at the Docker file, you can see it working its way down the list of instructions. Ultimately, it wrote out a container called .NET demo Docker file. I know the coloring's not easiest to see. But then we can verify that the file or that the container image is available by doing Docker image list .NET demo Docker file. Whoop. And this is again, so this command is I'm asking Docker, show me any images that you have stored within you with this name, and Docker responds and says, hey, you have an image out there called .NET demo Docker file. It has this sort of ID, which is kind of a hash of the image, a unique hash. And it says it was created 3 days ago. And this 3 days ago is because I first did this 3 days ago. And Docker's intelligent enough to say, hey, when you built this image, I didn't really need to save a new image to your system because that exact image already exists. So there's no point in duplicating it. I can just give you a reference to the image that's already out there because it's exactly identical to the image that's already that already exists on your machine. Once the image is created, you can run it. And in Docker, with Docker, there's a command called docker container run. This says go create a container by running the image named .NET demo build packs. And then this -p parameter, by the way, is something you need to pass to Docker to tell it how to pass network traffic into the container. The container, I believe, is listening on port 8080, but we want to have my machine listen on port 80. Oh, whoop! I picked it's .NET demo. Excuse me, I had the wrong image name. And if I go to, I might have the wrong. Did I do the wrong port numbers? Yeah, I think I did. So hold on, let me go back here. I need to have this -p command for mapping the network traffic in and out of the container set differently. But by the way, so I ran the application. It's now in a container. Effectively, if you look at what just popped up on the screen, this just looks like, running a .NET application normally. It's exactly the same as if I'd run it from my, from my local machine. And if I go to localhost and spell it properly, we're now running the application again. Now the application is containerized and running on Docker desktop on my machine. For some reason, I do get a different SQL Server error, but we'll just pretend, we're not going to worry about that for now. But the application is containerized and running in Docker. Now, we could take this container that we built right here, and we could take it over to Kubernetes and run it inside of Kubernetes. And but I want to take sort of a detour for a second and talk about other ways of building containers. I think most people who've worked with containers are familiar with using Docker and Docker files, but there are newer, more modern, more automated and easier ways to build containers nowadays. And one of them that we're going to talk about today is called build packs. And so this is build packs is it's an open source project. It is, I've heard people describe it as a tool for converting source code into container images. You can think of it as a tool that takes source code as input and a container is the output. Build packs are not specific to .NET. You can use build packs to build .NET apps, but you can also use build packs to build Java and PHP and Ruby and Go. And build packs are effectively equivalent to a multi-stage Docker file. Again, because they're taking the source code in, they're building the application, and then they're packaging up the build artifacts into a runtime container. And so that from a functionality perspective, they're similar to a multi-stage Docker file. And let me go back to the terminal. So how would we build this application using build packs? So build packs ship with their own command line interface. And by the way, just as an aside, build packs can run, there's a lot of different ways you can use build packs, but as a developer, I think the easiest way is to just use the command line interface. And the command line interface for build packs is, not surprisingly, pack. And you can run this pack command and give it different parameters, and it will build containers for you. And if I want to build this application, this ASP.NET MVC application using build packs, the first thing I want to do is delete my Docker file, because you do not need to give Docker files to build packs. One of the big benefits of them is that they're fully automated. In many cases, they will build your app and package it into a container with you having to do nothing. So I'm just going to delete my Docker file. And now if you look at what's in my folder, it's just all my .NET, it's all my sort of, it's just a clean .NET folder. It's almost like I just pulled this down from a GitHub repository. There's no build artifacts, there's no extra cruft, it's just my project file and all the CS files, etc. Now, to use build packs, I can simply say pack, build, and then give it the name of the container image I want to have created. And if I hit enter, it'll do what's necessary to create a container image for me. And the end result of this will be something more or less equivalent to what that Docker file did. But the beauty is I didn't write a Docker file. If you think about it, I didn't even tell build packs that I have a .NET app. I just said pack build, and it figured it out, and it built my application for me into a container. So, and I think we're about done here. And just I'm not going to spend. This is something where we could probably spend an hour on build packs. I'm sorry. Go ahead.
Does it come out bigger?
So in this case, it does. But there are ways to slim it down. There's configuration options, and you can specify what the base image is that gets combined with your application. And if you use a smaller base container image, you can slim it down. The one I'm using right now, I haven't bothered to sort of optimize it for space. Go ahead. Yep.
Can you repeat the question when it go online?
Yeah. Oh, I'm sorry. That's a yes. So I was asked, is this container built with build packs bigger than the container that was built with my Docker file? And it is at this point in time. There are some things I can do in build packs to shrink it down and perhaps get it smaller than the Docker file. I will say Docker files, you can get down into the minute details and optimize the heck out of them. You don't have that at quite as much control in build packs. The idea with build packs is that it automates away a lot of that stuff, and you don't have to worry about it.
Sure, yeah, I mean, I would 10%, 20%, it's 5 times bigger just because I get to do a better tool.
Right. Right. Go ahead, Alex.
So how does it think like Alpine versus Ubuntu or?
So there are. So he asked. So effectively, you're asking like, how does it decide what the base layer of the what OS? And I don't want to confuse people because I know we talked about a few minutes ago. You don't store. Containers don't come with an operating system. And that's sort of true. They sort of do. They come with. They don't need an operating system kernel, but a lot of the other files that make up an operating system, like the low-level C libraries and things that compose an operating system, do have to be put inside of a container. But it's a much smaller set of files than you would get if you had an entire operating system. And Alex was asking, how do you determine? So if I was using a Docker file, I can usually pick what base OS to use for my containers that I'm building. And there's certain OSs like Alpine that are known to be very slim and light. So you can do that same thing in build packs, but you need to, there's configuration options in here essentially where you say, this is the base OS I want to be paired up with, with my application. And it also has, and I'm going off script a little bit, but I think you can say pack, let's see, pack, there's some way where you can query, you can load it with different base images, and then you can say for different applications, for this app, I want to use this base image, for another app, I want to use another base image. But yeah, so you do have control over that. So let me jump back. So we use pack to build the application. The thing I forgot to mention is when we ran pack build up here, you'll see these stages it goes through: detecting, analyzing, restoring, building. Detecting is where it basically looks at the files in the current directory and it says, hey, this looks like a .NET application, or this looks like a Java application, or this looks like a PHP application. Then, and that drives the next step. Once it knows that this is a .NET application, and by the way, you can tell here, it's determined that my application is a .NET Core app. It's not only is it .NET Core, but it's ASP.NET, et cetera. So it tries to detect what type of application it is, and then we'll take the appropriate steps to build that type of application. And I'm going to sort of skim over a lot of these steps, but when it does get down to the building step, you can see it's building this application that, it now assumes the application is an ASP.NET Core application. And ultimately, it's just doing a normal .NET build. You can see it's down here, it's running .NET Publish, just like any other .NET app. And then the final step of a build pack process is exporting. And exporting is where it creates the output container that contains your application. And at the end of the day, you can see it successfully built an image called .NET Demo Build Packs. And just like we did with the image we built using Docker files, we can say Docker image list .NET Demo. And we've got both containers on here. We've got the .NET Demo container that's built with build packs, and we've got the .NET Demo container that's built with the Docker file. If we look at the build packs one, it's now, I have it now stored in my Docker registry locally, and you can see it's sitting there just like I did when I built the container with Docker. The one thing that's interesting about it is you'll see that it was created 41 years ago.
Windows 95?
No, it's not because of Windows 95. Actually, I think it's because it stamps. Build packs have this. It's actually 19. I think it's they're all stamped with a creation date of January 1, 1980, I believe. And that's because build packs have this concept of reproducible builds where they want to ensure, given the same inputs, they always create the exact same outputs. And so its default behavior is not to stamp even the current date of the creation date on the container. It always puts the same date on the container, January 1, 1980, to guarantee that, hey, if you build from the same source code, you're always going to get the exact same container spit out down to the last byte. But this behavior is, you can turn it off if you do want the current creation date tagged with the container. Yeah, some people in the room were not alive in 1980. I'll just show you just real quickly. I'm going to do a git clone of another repository. This is called Spring Pet Clinic. This is a Java application. I'm not going to spend a lot of time on this, but I just wanted to demonstrate. If I go into the Spring Pet Clinic directory and I type pack build Java demo build packs, again, I'm not giving it any additional instructions. I'm not even telling it it's a Java app. I'm not telling it how to build the Java app. It's going to do all the appropriate things to build this Java application and containerize it. So it's the fact that it automates so much of the process is really, really nice. Again, you can think of these as they take source code as input and they spit a container as output. Now I may not wait for this to finish because this Java application takes a long time to, oh wait, not so bad. I think we're almost done. Yeah. But it's very cool that the build packs will determine what programming language the application's written in and do the appropriate thing to build it. But so anyway, we just built the Java app. But I'm going to.
In a production world, how big are your configuration files for this?
So you can see here, I didn't have any configuration files, so of course, not more complicated applications. You can specify like a build configuration. It's sort of like, is it Ruby on Rails that has the sort of the convention over configuration? Basically, it has a bunch of default behaviors that'll work for most .NET apps and it'll work for most Java apps. But if your app doesn't happen to follow those behaviors or isn't compatible with them, you can override how it builds things, and there is a configuration file you can.
So even if you build servers, then you couldn't build packs and build servers?
Yes. So one of the ways you can use build packs is you can actually have them run inside a Kubernetes cluster, and then that Kubernetes cluster can be used within your CI pipeline for an organization CI pipeline. So that cluster will be used to build any applications using this build pack technology. So yeah, and that's what I was saying earlier, is that build packs, you can run them from the command line using this pack CLI, but you can also run them within Kubernetes as well. Go ahead, Alex.
Michael asks online, so does pack generate something similar to Dockerfile in your application directory?
It does not. The whole point of build packs is you don't need a Docker file. It just builds the container for you automatically. You don't you don't need to have a container file. And this is something, by the way, where if there's enough interest, maybe we could come back and do a deeper dive into this, because I'm not really prepared to talk about it, but there are ways of configuring build packs, and there are ways of specifying, like you had asked earlier, what's the base operating system that gets paired with my application, and how do I change that, and there's a lot of configuration. And by the way, if you dig into this pack CLI, a lot of these commands are about, the build command obviously is for building your app into a container, but the rest of this stuff is largely about configuring how this thing works.
So typically, developers never have to worry about containerization.
That's the whole point of this. Exactly. Is take containerization off the developer's plate. Developers focus on writing code. Don't have to worry about writing Docker files. That's the whole point of this.
Might be good to touch on, without Docker on your desktop or a registry that you're going to push this to, the container is not useful.
Right, right. Well, and that's a good point. So the next thing I want to talk about is, and we're about to run this application in Kubernetes, but there's one thing we need to do before we can run this application in Kubernetes, and that's put the container into an image registry. And so image registries are just repositories for container images. There's a lot of different image registries. All the public cloud providers have them. There's ones you can run on premise in your data center. But the most well-known one is probably Docker Hub. And you can just go to hub.docker.com, and that's what I'm going to use for today's demo. And anybody can go to Docker Hub and sign up for an account for free and use Docker Hub. Now, they have started instituting certain limits with free accounts, but you can still use Docker Hub to store your container images. And so, if we're going to run this application in Kubernetes, we have to store our application, our containerized application in an image registry. So to take my container that's now just stored locally on my laptop and get it to the image registry, I need to run two commands. And the first one's image tag. And essentially what I have to do first is I have to tag this container image with a new name, one name that's sort of compatible with Docker Hub. And the name that's compatible with Docker Hub is where you basically prefix your container name with your Docker Hub account name. And my account name is FJB4. So all I'm doing is prefixing my container name with my Docker Hub account name. Once I've done that, I can say Docker image push, and this is going to take that container and upload it or push it into Docker Hub. And so this is literally, uploading the data from my laptop over the network up across the internet up to Docker Hub. And this might take just a second. And so, by the way, go ahead.
Do you specify tags in your build?
I did. So when you use build packs, you have to give it, one of the parameters you give is a name, and that's the name that gets tagged onto the container. It's interesting, when you use Docker files, you don't have to give a name, and Dockerfile will just build the image and it'll just be named some random hash. But with build packs, you do have to give it some memorable name. So anyway, so this finished. It uploaded my container to Docker Hub. If we go back to the browser and I look at my Docker Hub account, and I'll zoom in a little bit so you guys can see. Let me refresh. .NET. Wait, did I do the wrong one? No, .NET Demo Build Packs. Let me see. Oop. I don't know what's. For some reason, when I type, it's like, let me refresh the page. Let's see, image push, .NET Demo Build Packs. Let's go back here. So here's Java Demo Build Packs, .NET Demo Dockerfile, but there should be .NET Demo Build Packs in here somewhere. Maybe it, usually the most recent image you uploaded floats to the top of the list. But let me, did I get an error? Latest digest. Let me try just pushing it again and see if anything changes. Yeah, it says it worked. Here's the name. Here's my Docker Hub account. Huh. I don't know why that is when I type download.
Navigate directly to it.
Yeah, it's just weird. It's acting strange, but here, let's see this. .NET Demo Build Packs. Well, I guess it doesn't matter. We can work around this. I'm curious. Something strange is going on when I upload this image to Docker Hub. I happen to, instead, what we can do is I can upload the one we built with the Docker file, and it shouldn't make a difference. I got to tag it, Docker image tag, .NET demo Docker file. Whoop. I'm going to tag it with .NET demo Docker file, and then Docker image push .NET demo Docker file. Let's see if this wants to cooperate.
Yeah, I saw something the other one said Java, and it didn't look right.
Yeah, .NET demo.
From Java.
Huh. Where do you see that? Let's keep. Huh. Yeah. Well, let's see if this worked. So here's the Docker file. And the other thing is it says it's last pushed 13 days ago, but it's possible that even though I just did this, that this is because the one that I'm uploading is exactly identical to the one that was already on Docker Hub. But point being, once you've built your container locally, you upload it to a container registry, one like Docker Hub. And once it's in the container registry, now you're ready to run your application in Kubernetes. And let's jump back to the slides for a second. Here we go. And I'll talk about Kubernetes, and again, this is just gonna be 2 or 3 slides, and then we'll demonstrate running the app in Kubernetes. So Kubernetes is, and I'm not gonna read this first bullet point, but I think I stole that off of Wikipedia, and that's probably the most, if you wanna be precise about what Kubernetes is, that's probably the most accurate description of it. But essentially, if you just wanna talk about it simplistically, Kubernetes is a way to run containerized applications on clusters of servers. Kubernetes is also, by the way, if you start digging into it or reading about it, you'll see oftentimes online it's referred to as K8S. And I just point that out because I know when I first got started with Kubernetes, it kind of caught me off guard. But K8S is just the abbreviation for the word Kubernetes. Someone was too lazy to type it out. So then the next question you might have is, okay, if Kubernetes is a cluster of servers that can run containerized applications, how do I interact with it? How do I tell Kubernetes to say run an application? And you do that using a tool called kubectl. There's 2 camps of how to pronounce that. It's kind of like tomato. But in this case, kubectl is pronounced by some people as kubectl and others as kubectl. Either, I don't think there's, it's like soda or pop too. We could argue all day. I'm in the kubectl camp, but kubectl is equally valid. So kubectl is a command line tool, and you use it to feed commands to a Kubernetes cluster. Those commands are fed into the Kubernetes cluster in a file formatted in YAML format. YAML is a markup language, and we'll look at that in more detail in a second. And that last line shows you how you might pass a YAML file of instructions into a Kubernetes cluster. You would type kubectl apply -f, and then you'd give it the name of the file with the YAML instructions that you wanted to pass in. So this is an example of what a YAML file that you could give to Kubernetes would look like. This is, so by the way, YAML, just really quickly, if I explain it just very simplistically, it's a bunch of fields on the left, and then there's a colon, and then the value of the field is on the right. And the thing that this YAML file is doing in Kubernetes is creating something called a deployment, and a deployment is a way to run an application in Kubernetes. This file is creating a deployment called Nginx deployment. It's creating, it's specified that it wants to run 3 replicas of the application that's being deployed into Kubernetes. And so Kubernetes has functionality within it to scale your application out to run as many instances as you want. So in this case, they're going to run 3 instances of this application. And last, I'm going to sort of skim over a lot of this stuff. The thing I do want to point out down here is this image colon down here is just to say that ultimately, at the end of the day, Kubernetes is running a containerized application, and the container image that it's going to run is referenced down here. So in this case, it would be running a container image called Hello World, and this is and this is where if we ran our .NET demo container, we could put that name in here as well. There's a few bits of terminology in Kubernetes I just want to run over real quick because they'll be relevant later. When you build a deployment like one specified in this YAML file, it actually creates a hierarchy of objects in Kubernetes. It creates the deployment at the top of the hierarchy. It creates a replica set. And then at the lowest level, there's these things called pods that are created. And if you recall, this YAML file here says, if you look up here, we have 3 replicas. So it's going to run 3 copies of an application. This deployment file here is going to create a single deployment with 3 pods. Each pod is going to contain 1 instance of the application because there are 3 replicas. If I had 1 replica, there would be still 1 deployment with 1 pod. If I had 10 replicas, there'd be 1 deployment with 10 pods. Just be aware that inside of Kubernetes, the pod is where your application actually is executing. That's where your container image is running. And the last slide I want to just point out in Kubernetes is I want to talk about something called services. Services are how you talk to your application in Kubernetes. So if you want to talk over the network to an application that's running inside a Kubernetes cluster, well, let me back up. If I ran this deployment file as is to create an application and run it in Kubernetes, it would run in Kubernetes, but it would not be able to be accessed from outside over the network. In order to access this application from the outside world over the network, you have to create a service. And I'm just pointing that out, that without a service, there's no way to communicate with your application. Now, so let's deploy our application into Kubernetes. I'm going to show you. So again, we talked about, well, actually, let me back up. So we talked about Docker Desktop a while ago. If I'm going to run, if I'm going to deploy something into Kubernetes, obviously I need a Kubernetes cluster running somewhere. I'm going to start off by running it on my local machine. And the easiest way to, there's a bunch of ways you can run Kubernetes on your local machine, but I think the easiest is using Docker Desktop, where if you go into the preferences of Docker Desktop, there's a Kubernetes option down here. You can click Enable to Kubernetes, apply and restart. And if I wait a second, I'm now spinning up a Kubernetes cluster on my laptop, and it's a cluster of one. It's just a single server cluster. But this gives me a perfect development environment to use to play around with Kubernetes. This shouldn't take too long.
Is Docker Swarm still alive?
It is still alive. I think so. So Alex asked if Docker Swarm is still alive. Docker used to have its own sort of proprietary container orchestration technology called Docker Swarm. It was a lot like Kubernetes. I think it's on the decline because Kubernetes is open source, and it seems like the industry is sort of standardized around it. So my impression is that Docker Swarm is on the way out, and Kubernetes is probably replacing it. And I think it's, it probably is a giveaway because even Docker, has Kubernetes baked into it. But so now I've started up a Kubernetes cluster on my local machine. I can use this kubectl command line interface like we talked about to interface with this Kubernetes cluster I just created. And so when you use kubectl, by the way, kubectl, you point it at a Kubernetes cluster. You say kubectl you configure it to talk to a specific cluster, and then all the subsequent commands go to that cluster. And you configure it to talk to a cluster this way. So I can type get context, and this will tell me what Kubernetes cluster my kubectl command line tool is aware of. And the clusters my command line tool is aware of is there's a cluster called Docker Desktop, and then there's another cluster called GKE. It's a much longer name. And this is hard to see because of the wrap, but there's this current column over here with an asterisk on it, and the asterisk is next to Docker Desktop. And this indicates that my kubectl is now configured to point to this Docker Desktop Kubernetes cluster, which is the one I just started on my PC. So when I issue commands like kubectl get pod, which is a way of querying a Kubernetes cluster for what pods are running on it, I'm now querying the cluster running in Docker Desktop on my local machine. All right, so how do I run our ASP.NET MVC app in this cluster? Well, to do that, I'm going to do another kubectl command, and I'm going to have to change this because I'm going to have this run .NET demo, the version of the container we built with a Docker file. But this command here is telling Kubernetes to create a deployment, call the deployment .NET demo, use the container image called fjb4.NET demo Docker file. So it's going to grab that image from Docker Hub. And then it's going to specify a port. I got something blocking the bottom of my screen, so I can't see the rest. But and then I have replicas set to 1. That says run one instance of my application. And let me pause there for a second. So all that stuff will create a deployment on Kubernetes, and it would run it for me. But you might say, John, but you lied. John, you told us you have to pass in these YAML files to tell Kubernetes what to do. And so technically that's correct. You do have to pass in YAML files into Kubernetes. What this command does is, if you think about it, you can think of it as this is a command that is shorthand for creating a YAML file. And if you could give this command to Kubernetes or to kubectl, and kubectl is just going to help you out by creating the YAML behind the scenes and then passing it into Kubernetes. But at the end of the day, there's still YAML being submitted to Kubernetes. This is just shorthand for it. But what I'm doing with this command is I'm telling kubectl, dry run, don't execute this command. Just execute or do this, but don't actually create the deployment. And then lastly, I'm telling it to output this command as YAML. So in essentially, take this shorthand command and expand it to the full YAML that it corresponds to. And then I'm going to redirect that YAML to a file called deploy.yaml. So if I run that, it just created a file called deploy.yaml, and we can edit that file. And this file was just created by that kubectl command. And again, so it's running a command or running our application.NET demo, one replica, and down here it's referencing our container image, .NET demo Docker file. Before I run this app, I want to make one quick change to it, and then we'll deploy it into Kubernetes. Let me come back here, and then we'll talk about what I've done. Oh, not the Docker file. What am I doing? So I have this YAML file here, and I'm going to take these last few lines, copy them, take them over to Visual Studio Code, paste it into here. And what I'm doing essentially is this bit. I'm telling Kubernetes, when you run this containerized application, I want you to inject a couple environment variables into the runtime environment of that application. And the two environment variables are pod name and pod IP. And I'm telling Kubernetes, without getting into too much detail, I'm telling Kubernetes populate these with the name of the pod and the IP address of the pod that is running the application. And by the way, every pod has a unique name and IP address in a Kubernetes cluster. So if we go back, I can now do what I showed on the other slide, where I say kubectl apply -f deploy.yaml, and I'm passing in that YAML file, this one right here, and we're passing this whole file into Kubernetes and telling it to essentially execute it. And if I say kubectl get deployment, and I query kubectl for what deployments it's aware, it has running within it, you can see now we have a deployment called .NET Demo. And if I say kubectl get pod, there's one pod, because remember I set replicas to 1, so there's only one pod now running for that deployment. And so our application's running within Kubernetes, but as we talked about earlier, you can't access it without creating a service if you want to be able to access it over the network. So I'm going to create a service real quick so we can access it. And I think I might have to change the ports because we're using the Docker image. Yeah, so let me try this. This command is essentially doing the same thing we did with the kubectl create deployment command, but this is doing the same thing but creating a service. I'm telling kubectl expose my deployment, and by expose, you're essentially saying expose it over the network. Expose my deployment that's called .NET Demo, and then I'm giving it a bunch of parameters to it to tell it how the service should be constructed. But I'm also saying don't actually create the service, just create the YAML for it and save it into a file called service.yaml. So if we go code.service.yaml, I now have another YAML file that creates a service, and this service should allow us to talk to our .NET Demo application if I've done this correctly. So I'm going to feed that into Kubernetes by saying kubectl apply-f service.yaml, and now it's created a service, and I can verify it by saying kubectl get service. And I should have a service now called .NET Demo. If I go to my browser, and if hopefully I got the ports right. Yeah, it's now, so now our application, we've been at this for about an hour, but the application is finally running inside a Kubernetes cluster, and it's running inside the Docker desktop cluster on my machine. And by the way, now because we've told Kubernetes to create these environment variables for pod name and pod IP, those are showing up within the Kubernetes or on the web page as well. One other thing I'll show you real quick is with kubectl, you can say kubectl logs, and you can give it the name of a pod that's running within a Kubernetes cluster. And remember, the pod is where the application is actually running. And when you check kubectl logs, it spits out the log file of your application. So this should look very familiar to any .NET developer. This is just your .NET logs. So cool. So let's pretend we'll make up this hypothetical situation where I'm a developer. This is the application I wanted to build. We're going to deploy it in production into a cloud environment, but I wanted to test it locally on Kubernetes on my machine first, and we've just done that. But now let's move it into the cloud and see what we need to do. When it comes to running Kubernetes in the cloud, there's a bunch of ways to do it. Amazon has something called EKS. And this is within Amazon. If you have an AWS account, you can go in there and you can spin up a Kubernetes cluster in a few minutes using this. Azure has something called AKS, which is Azure Kubernetes Service. It also lets you create a Kubernetes cluster. And then last but not least, Google also lets you create Kubernetes clusters using something called GKE, Google Kubernetes Engine. And my point being is that you can run Kubernetes in any of these environments, and it's all going to run in a consistent way. So what I've done in my local Kubernetes cluster running on Docker Desktop will work on Azure, it'll work on AWS, and it'll work in Google. And if you're running Kubernetes in your company's data center, it'll work there too. I'm going to demonstrate today just using Google to deploy our application to the cloud, but I could have used any of those environments. First of all, I have to change accounts because I don't want to get charged I want to make sure my company gets charged for this cluster and not me. Yeah, well, so yeah, I don't know how much it is, but it's a few bucks a day. So this is Google GKE. This is their, Google's Kubernetes engine. And by the way, what I'm showing you here is going to look similar-ish, no matter whether you're using Google, Azure, or AWS. But in this environment, it shows you a list of all the Kubernetes clusters you've created. I have one cluster that is running already. I could create another cluster by hitting this Create button. And you can answer a bunch of questions, but like the most significant questions typically when you're creating a Kubernetes cluster are how many nodes or servers do you want within the cluster? So this says 3, but I could make that 30 or I could make it 1. It's totally up to you. And then lastly, you can also pick all the nodes or all the servers within the cluster are VMs running inside of Google. So you can pick what type of VM do you want for each of those nodes. Do you want a 2 CPU, 4 GB node for each of those 3 nodes, or do you want 32 CPU, 128 GB of memory node? So that's totally up to you as well. Once you answer, and a lot of it, how much do you want to be charged for this thing? But once you've answered all these questions, you just hit create, and it's going to create you a new Kubernetes cluster. And this probably would take 5 or 10 minutes, and I'm not going to wait for it to finish. So I'm going to do like a cooking show where we'll jump back to the cluster I already have up here. But in 5 or 10 minutes, we'd have this other cluster ready if we wanted to use it. In Google, if I wanted to connect to one of these clusters, I can click these 3 dots over here, hit connect. It gives me a CLI command I can run. And if I take it over to my terminal window and paste in the command that it gave me and run that, this is going to change my kubectl configuration so that I'm now referencing the cluster out in the cloud. So I'm now, instead of talking to my cluster running on my local machine, the one that's running in Docker Desktop, I'm now talking to the cluster out in Google. And you can verify this by saying kubectl config get context. And you can see I used to have an asterisk next to Docker Desktop, but this asterisk has moved down and it's now next to this GKE cluster. And if I type commands like kubectl get pod, I'm now querying that cluster that's running in Google. So now, and this is sort of the fun part. And what I'm trying to emphasize here is that Kubernetes is Kubernetes. What we did in my local Kubernetes environment is going to work equally well in this cloud environment. So I'm just going to take those 2 YAML files we built a minute ago, and I'm going to say kubectl apply, and I'm going to apply this first YAML file that creates the deployment for my application in Google, and then I'm going to say kubectl apply -f, and I'm going to create the service necessary to access that application in Google. I didn't have to change anything. Those are the same files that I was just using in my local environment a minute ago. And now we can do things like kubectl get deployment, and we should see it's running out there in Google. Kubectl get service. We have a service for our .NET demo application. The interesting thing here, by the way, is you can see this external IP is pending. Google's going to give me a real public IP address that'll let me access this application. And sometimes it takes a minute. That's why it's still pending. When it comes up, if you guys have a laptop or a phone, you could plug in this IP address and you could access it just as easily as I can, because it'll be running on the public internet. So there it is. So if you cared, you could try punching this in. But if I copy that IP address and we go to a new browser window, and I'm just going to plug in that IP address that we got. Here's my application running in Google as in a GKE Kubernetes cluster. And it's printing, it's working exactly the same way as it was when we had it running in Docker Desktop. Now that we have it running in a Google cluster with multiple nodes, there's some things we can play around with that are kind of fun. And for example, I can come back and I could edit our deployment YAML. And I could change replicas from 1 to 3. Maybe this is an e-commerce app and we want to scale up to more instances to handle the load. So I'm going to run 3 instances of my application. So now I could say kubectl apply, and basically I'm just going to feed that same file back into Kubernetes, and the file now has The only difference is replicas was changed from 1 to 3. What is the effect of that? Is now if I look at the number of pods within my application, you can see it's starting 3 of them up. 2 of them are just starting right now. You can see their age is only 6 seconds, but this is the original, the OG instance of the application. It's been around for 2 minutes. But as soon as I change the number of replicas to 3, Kubernetes is now saying, oh, I need to add 2 more instances to bring it up to 3. So by the way, these 2 aren't running yet, they're just creating, but if I check it again, now you can see all 3 are running. And the other thing that's interesting about it is, if I can get this to work, if I come into the application, and I'm going to open the dev console, what I want to show is Kubernetes will load balance me across those different pods. Go, yes, Alex.
Will that go to the containers you're getting latest? Will it grab the same image starting on the other VM?
So it'll reuse the same container image. It'll ensure that the same image is used across all 3 pods. Yes. Yeah. So you're right. Because that would be you don't want to end up in that situation where one pod is running one version of your application and another is, and by the way, that also speaks to when you reference your what container to run down here, you probably should, I haven't specified what version of the container or which specific version of the container to use. You probably should in a real world scenario. So you could say, I don't know, if you've tagged your containers with a version number to ensure that you're using the exact one you intend to be running. I'm going to try refreshing the page here, and we'll see if this IP address changes. So it's 3.7. Did it do it? No, it's still 3.7. So sometimes I get, there it goes, 2.3. All I'm trying to demonstrate here is I have 3 instances of my application running. Kubernetes will automatically, again, I didn't have to read about how do you in Google create a load balancer to load balance traffic across 3 different web applications. Kubernetes is doing this for me, and how I do it in Kubernetes is going to be consistent no matter where I run Kubernetes, no matter which cloud provider I use or whether I run it on my local machine.
Always begs the question when you start talking about load balancing session data that needs to be consistent across different requests.
Right.
Is that something?
Yeah. So and that's a good question. So. And that's why I had to open the dev console and I have to come up here and say empty cache and hard reload. And I'll be honest, I don't know the exact answer to your question, but if I close that and I just start refreshing, I think there's some sort of session affinity where I'll get stuck on one of the pods. Yeah, so to ensure, but you're right. That's how exactly that works. I'm not 100% sure, but it is. Typically, as a user, when you come into the application, you'll be assigned to one instance and you tend to stick to that instance for the duration of your stay. Yeah, yeah. So that's cool. And by the way, so we're nearing the end of the demo. There's a 1 or 2 other things I want to show real quick. Kubernetes has this concept of desired state, and this runs throughout the entirety of Kubernetes. And the idea is you tell Kubernetes the configuration of your application, and Kubernetes monitors your running application and ensures that it maintains that state, the desired state, the desired configuration that you gave it. One example of this is I've created this deployment with 3 replicas. So I've told Kubernetes I want 3 instances of my application to always be running. So Kubernetes is watching my app, and it's watching to ensure that 3 instances are always running. Even to the point where if I do this, kubectl get pod, there are my 3 instances of my application because I have replicas set to 3. But if I come in here and I say, Kubernetes delete, and I'm going to give it one of these pod names, .NET demo dash, am I going to make me type this whole thing in? I think it is. So I'm going to delete this pod. Oh, you know what? I know why it didn't work. I need to say delete pod. But so that deleted one of the pods. Now keep in mind the deployment was configured to have 3 replicas. So if I go back and we query, oops, if I query for the number of pods running, you'll see now there's still 3 pods running. Because Kubernetes, as soon as I kill one, it says, oh, you're supposed to have 3 running, and it'll immediately start a new instance. And in the same way, if your application, one of your instances crashed because of a, not that anyone ever makes programming errors, but if you had a bug and it crashed, Kubernetes would restart your application to always ensure that the specified number of instances are running. And this is, by the way, this is another one where you can see the one that I deleted was removed, and then Kubernetes immediately created this one, and I know it's this one because it's the newest one. It's only been around for 14 seconds. It's the one that Kubernetes created to replace the instance that I deleted. So that's kind of a neat thing about Kubernetes, is that once you specify the configuration to it, it ensures that your application continues running according to that configuration. All right, so for my finale, so we talked about SQL Server all the way at the beginning of this. And I just want to point out, you can run things like most databases, most message queues, most backing data services today come as containers, and you can run those within Kubernetes. For our app, I have a YAML file over here that I took from Microsoft and I tweaked it a little bit, but this YAML file has all the Kubernetes configuration necessary to run SQL Server in a Kubernetes cluster. And so I'm going to create a file called deploy. Yeah, so let me paste this in. So there's going to be things in this YAML file we haven't talked about, and I don't really intend to get into that today too much. But I will say, like you'll see within this YAML file, I'm creating a secret. This secret contains the SA password of and it's obfuscated down here, but it contains the SA password necessary to access SQL Server. There's a persistent volume claim. These are things that you use in Kubernetes if your application needs to have storage to write to. And so this is where SQL Server is going to be writing its databases to. And again, I'm glossing this. Again, we could probably spend a lot more time digging into this more deeply. But down here, this will look familiar. We're creating a deployment called MS SQL deployment. And this is where SQL Server itself is going to run. I'm only going to run one replica of SQL Server, one instance of it. And there's some configuration you give it down here. But the significant thing is this line, where Microsoft provides a container image for, and this is SQL Server 2019, and that allows you to run SQL Server as a container. And again, there's a bunch of other environment variables and things that you can pass into SQL Server. I'm not going to worry about it too much. And also, I'm going to create a service that lets us talk to SQL Server. But I'm going to take all that and I'm going to pass it into SQL Server with kubectl apply. And it's going to create those 4 different things that are necessary for SQL Server to work. And if I say kubectl get deployment, we should now have 2. We should have one for the .NET demo application. We should have a second one for SQL Server. And if we go back to our application for the, so we've been seeing error messages down here for the entire evening. Now there's a SQL Server instance running in this cluster, and it should be able to connect to it. And if this works, this error should be replaced with a list. I think it's a list of table names, just to verify that it was able to communicate with SQL Server. Is it working? No, it's. Oh wait, am I? Let me see something. Kubectl get pod. Let's verify that it's running. So SQL Server is running. Yeah. And it's not cooperating for some reason. Well, so I'll spend a minute debugging this, but it's the demo gods. It's like it works when you're at home, and then as soon as you get up in front of people, it doesn't cooperate. Why? So kubectl logs. Let's look at the logs for our application, although I don't think we're going to see anything in here. Oops. I think I misspelled it. Yeah, you can see it's just, the problem is I have a try catch around the all the SQL Server errors, so it's not going to show anything in here. Let's see something. I wonder if this has to do with me not being able to push that new version of the app up to Docker Hub. I'm going to backtrack a little bit, and I apologize. Usually this should just work first time around. I think I goofed something up earlier. Image tag, Docker image push, .NET demo. Oh wait, you know what? I just did that one wrong. Docker image tag. I'm going to re-push my application to Docker Hub just to verify that the one with the latest version of the code is out there and running. Because I suspect it's grabbing in one that I'd done earlier that didn't have the code to connect to SQL Server. Docker image push. And I want to push the build packs version. At least that's the one I had tested with earlier. And it says it's out there.
So, latest is always a dangerous tag because it's a rolling tag. I think it's not getting that latest digest.
Yeah, so that's actually a good question, Alex. You're right, because I don't have in my deployment file, I don't have a tag in here. However, I do have this. So this should show every single time it should be going out to Docker Hub and grabbing whatever the latest version of the image is. I'm going to try to see what happened if I change this to use to the build pack version of the container image. Just because this is what I had done in my rehearsal earlier and it worked. So I'm going to say .NET, or excuse me, .NET kubectl apply -f deploy .yaml, and I believe that means that if I say kubectl, and so another command you can do in kubectl is describe, and I can describe a deployment, and this will just basically spit back some of that YAML that we were looking at. So I can say .NET demo, and I just want to make sure what we have in here. So it's running the .NET demo build packs image now in Kubernetes. Now, the other thing I'm going to have to change is my service. Close that. And I think the target port has to be 8080 for the build pack container. The build pack container and the Docker file container use slightly different ports. That's why I'm doing this, or making that change. And I'm going to say kubectl apply -f service.yaml. And then let me check our pods to see if they're all running. So this is interesting. It can't pull the image. So yeah, so I apologize. We'll just have to, maybe some other time I can come back and let you guys know what was, there's some glitch with the SQL Server part, but it'll take me a few minutes to figure it out. But take my word for it. We have SQL Server up and running in the Kubernetes cluster, and it's just a matter of getting the application configured properly so it can connect to it. But I'm happy to take questions now and go over any of this stuff. I know I've covered a ton of stuff. My intention here was mostly just to talk to you about containerizing applications, introduce you to the concept of build packs, and also just make sure you recognize that you can run Kubernetes virtually anywhere, and it gives you sort of a consistent deployment environment. So you can move your application around to any place that Kubernetes works, and your app's going to work consistently, and you don't need to. If I move my app from AWS to Azure, I don't. There's very little to learn or that changes when I switch between Kubernetes clusters and those environments. Yes, sir.
How difficult is it to add auto scaling?
So that's a good question. So there is auto scaling in Kubernetes that you can put criteria on an application, and you can do things to say like, what's the default number of instances of your application to run? If the CPU usage reaches this level for a certain period of time, then increase the number of instances. Or so that's all in the YAML file. Yes, it's in Kubernetes. There's horizontal auto scaling, and that does exactly like what you're describing. So you're right. So you don't have to manually adjust the scaling when increase it for Black Friday and then turn it down after it's over. Yes, sir.
Will that increase the pod or increase the VMs?
So that's an excellent question too. Does it increase the pods or the VMs? You can do both. And I'll show you this. And some of this is like some of the cloud providers have some advanced features. So when I create a cluster, in fact, I think I can just click on an existing cluster. And the cluster itself can auto scale. If I edit the configuration, I think, or is it not going to edit cluster below? Security, metadata. Here, maybe just look for, yeah, here. So there's vertical pod auto scaling. Vertical pod auto scaling, I think will move your app. Long story short, there are ways to do it. There are ways in Kubernetes basically to say only run 3 nodes within a cluster. If those nodes get busy enough, add more nodes. If those nodes are idle, decrease the number of nodes. And at the same time, you can also scale at the application level to say how many instances of your app to run. So you can scale in both of those ways, yes. So, and I guess if there are no more questions, we can call it.
What's your favorite service discovery?
Well, so you, to some degree, you don't need service discovery when you use Kubernetes. Kubernetes, when you create, so we talked about services in Kubernetes. You just reference your, so if you're talking about a microservice architecture, you can just reference the service by the name that you define in the service configuration in Kubernetes. And Kubernetes will, then you talk to that and it'll map traffic to all the instances of the application. You can use something like, so the only service discovery other than that I'm familiar with is Eureka. Are there other ones that you know of? And by the way, I probably should back up and just explain what service discovery is. And service discovery is, how do you know, especially when you have a distributed application and I want to talk from one microservice A to B, how does microservice A know how to get a hold of how to communicate with B? Because in a microservice architecture, there could be many instances of B and you don't know what servers necessarily that they're running on. So oftentimes you use something called service discovery, where there's essentially a service running somewhere that's a phone book. And all your services, when they start up, they register themselves with this phone book, and everybody can go to the phone book to say, okay, where is service A running? Where is service B running? And the phone book is updated with the location of where all those things are. So you can do that to some degree in Kubernetes if you use, if everything's running within the same cluster. You can just use the service name that's defined when you create the service, and it negates some of the need of a separate service discovery system. So, yes.
All the nodes would be the same region, same data center?
To the best of my knowledge, yes. Now, and some of this, like a lot of the cloud providers are trying to one-up each other, and they add features that maybe other ones do not have. I would think you would be better off having everything within the same region. If what you could do perhaps is run multiple Kubernetes clusters in different regions and have your app spread across those. But each cluster you probably would want within a single region. You could even have clusters. You could run one on AWS and one on Azure, there are ways to load balance across both of those. Yeah. Now, I don't know how many people would actually need to do that. You know, it seems a little expensive and complicated, but anything else? All right. Well, thanks, everybody.
Thanks, John.
Yeah.